This is eHobbyist Blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we'll be installing AC power line filtering and surge protection. When I first came across this line filter module, my first inclination was to take it apart and check each of the components. So I proceeded to take a digital voltmeter to it and check each one of the components. And I have this gizmo that looks like somebody's Arduino project from China, and they're using that to check the inductance. Actually, this thing works, and works well as far as I've been able to test it. Here is the circuit diagram for this line filter. It's got enough room in the physical box to be able to contain my varistors. Does this thing actually work? Based on what it's got printed on the case, I would expect to see a flat response from a very low frequency on up to something comfortably above 400 hertz. And then at some point above that, a 3 decibel point where the response starts dropping, and 1 decade of frequency above, I would expect to see a drop in response down to 20 decibels. There are any number of ways to determine the frequency response of a filter, but one of the ways is to run pink noise through it and subsequently measure the output. And since my Wriggle oscilloscope is busy wriggling its way into the garbage can, I'm going to be using an audio spectrum analyzer. The spectrum analyzer shows, as I expected, flat response all the way out to 1 kilohertz, where the response drops 2.5 decibels. Then you get a fairly steep decline at 10 kilohertz. I expected to see 20 decibel drop, but what I'm actually seeing is a 15 decibel drop. Good enough. What I've established is that this thing is a working low-pass filter. The original manufacturing soldered capacitors directly to the case, using the case to conduct as chassis ground, and that's okay. And I wanted to use the same method of construction. My only question here is, can I solder directly to this steel case? So I've got the Hakko soldering iron dialed up to about 400 degrees Celsius. And I was expecting to find trouble here, but it's apparently very easy to do that with the soldering iron at temperature. Now I'm using a wide chisel tip, and that helps in transferring heat. But apparently the Hakko is fully capable of doing this sort of thing. This worked surprisingly well. Now I've got blobs of solder, and subsequently I can solder my varistors in. And right now I want to clean up. As far as I'm concerned, surge protection is a mystical art, and I don't want to establish crazy paths that a surge can take, and I certainly don't want to leave behind flux residue. What I'm cleaning it with is acetone and isopropyl alcohol. Now let's take the first varistor and scrape down the leads. Oxidation on the outside, as is obvious. In this particular varistor, I'm going to try to position across the line side neutral and hot lines. Bend that into shape. Slip it in, and what I want to do is crimp it, try to relieve some stress on the solder joint when I solder it. As it turns out, it's not really very easy to do. There's not all that much space in here, and crimping it and tying it off tight is a rather difficult proposition. Just getting a side cutters and a diagonal and a needle nose pliers in there is a difficult operation, much less getting my fingers in there. Let me just hold this to the side, try to crimp it a little better, solidify its position, and get it ready for soldering. I'm soldering it first to the neutral line. Next, I want to position the wire lead to the hot line and solder that. Now I have a varistor attached across both active leads. Next varistor is going to go from neutral to chassis ground through the case. Wrap that lead around, position it properly. It's kind of difficult to work on this thing with limited space inside. What I really need is a angled needle nose, and in retrospect should probably have used a hemostat to hold things in place. Liquid flux on this. One end of the second varistor gets soldered to the neutral line. And now the second lead of this varistor is going to get clamped into place by a reverse tweezers, which could have been a hemostat, and get soldered to the case with that blob of solder I put on there just a while ago. Okay, not bad. And finally, the third varistor is going to go from hot line to chassis ground via the case. Position this lead into place and crimp it and get some liquid flux on it and solder it in place. The other lead of the varistor gets soldered to chassis ground through the case. And by George, I've got all three varistors in place, soldered, and there was indeed sufficient room to perform this operation. I'll get the garbage out of this and clean up, get the flux residue out of the solder joints. Okay, I've got this thing done. Now I need to start drilling some mounting holes, and the first part of the process is a template for a center punch. And I'm going to drill one hole and one hole only. I've got to deburr this hole, first on one side and then the other. And then clamp the base plate and use that as a template to drill the second hole, which is kind of critical between two vent lines. And unscrew the base plate, the screw being one of the ways I clamped it. And deburr that hole. Needs to be deburred on both sides. Now, next part of the process is to set up the quick disconnects. I want to test the fit on these things. Unfortunately, when I did the original panel layout, I forgot about the sleeves on these quick disconnects, so I need to bend two of them. First one I'm going to do is the neutral line. Strip that, apply a disconnect to it. And that gets slugged in to the top of the filter. Next, cut the hot line wire to size, strip it, and slap a disconnect on it. and crimp that disconnect. There are a lot of crimped connections I've got here, which causes me worry. And then finally, I'm going to attach the chassis ground coming from the AC input module. And I'm going to do it in such a way as to just scrape off the insulation. I don't want to break the wire. I want to have one continuous wire establishing chassis ground. And let's crimp this and attach this chassis ground disconnect to the line filter. Now line filter and surge protector. Mounting the line filtering surge protector, or surge protecting line filter. I'm using what is probably number 6 screws for this. Hey, whatever is around. And I'm using, in this particular case, a kind of a flexible nut driver. I wish I knew where I got this from. Probably one of the more useful tools I have, because you can squeeze into very tight spaces. Now that that's mounted, there are 2 more wires to be attached. The load side of the filter. And attach disconnects to it. The load side, neutral and hot lines will go to the primaries of the transformers. So we have neutral, hot line, and chassis ground wires. In this video, I installed, tested, and diagrammed an old line filter and indicated how surge protection would be added. I installed the surge protecting MOVs. I cut, stripped, and connected the line side and the load side wiring. And I drilled mounting holes and attached the line filtering surge protector module to the enclosure. In the next video, we will be installing transformers to feed both internal and external power supplies. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.